So today I want you guys to open up to lesson 2.1 in your workbooks, okay? And we're going to be dealing with the question, how crowded are we? Okay? So for our objectives, so students will understand that population density is a ratio of a number of people per unit area. Proportionality can be used to compare population densities. Students will be able to calculate population densities, determine if two population density ratios are proportional to each other, and compare and contrast populations via their densities. So let's look at the first problem. So the first problem, okay, says using ratios to measure population density. So do you ever notice that during rush hour, there are more people packed in a subway car than late at night? The size of the car remains the same, but the number of people in the car has changed. What has changed is the population density. Okay, and that's important. So population density. So population density is used to analyze such phenomena as spread of diseases, the distribution of resources, and the planning of urban spaces. The population density is defined by the following ratio: number of people over area these people occupy. Okay, so basically when we're trying to figure out the population density, or what we're trying to figure out when we use this population density formula, is how people are spread apart. Okay, so we're going to be using this ratio, number of people or the population over the area these people occupy. So below is a table showing the population and area of the 5 boroughs that make up New York City. So we have the Bronx, we have Brooklyn, we have Manhattan, Queens, and Staten Island. My first row tells us the area, which square miles. So the Bronx is 42 square miles, Brooklyn 71 square miles, and the population. So without doing any math, I want you guys to tell me, estimate the order of the New York 5 boroughs from most dense, so the more crowded it's going to be, to the least dense. So why don't you guys, in your books and also on that puzzle, the question will pop up, is which borough do you think is most crowded and why, and which borough do you think is the least crowded? So give me most dense, order them from crowded to least dense. Okay, so this question A really wasn't, there is no right or wrong answer yet, okay? And I'm going to assume that most of you guys probably said Queens was most dense and Staten Island was least dense, and you probably looked at the population, okay? So let's go over how to actually determine or calculate the population density. So we're going to do Bronx, okay? So if I want to know the population density of the Bronx, there's some ratio that I need to set up. So take a second and I want you to determine which ratio I'm going to be using. So you're going to be using the ratio that has my population over area. Okay? So my population of the Bronx was 1,472,654 people, and we're going to get used to putting these units over 42 square miles. So when I go into my calculator and I divide this, I get 35,063 people over 1 square mile. Okay, so every mile that I walk in the Bronx, there is roughly I don't want to say there's roughly 35,000 people. If I were to take every person in the Bronx and spread them out equally and then walk every mile in the Bronx, every mile there'll be 35,000 people. So let's look at Brooklyn. Okay, and again with Brooklyn, I'm doing population over area. So 2,736,074 people. Ooh, there should be a 0. Over 71 square miles, and I get 38,536 people over 1 square mile. Okay, so Brooklyn's population density is a little more dense because there's more people in this square mile than my Bronx. So right now, I want you guys to determine Manhattan, Staten Island, and Queens. So Manhattan, okay, I got 73,663 people per square mile. For Queens, I got roughly 22,068 people per square mile. And let's pick another color. Let's do purple. Staten Island, okay. I got about 8,547 people per square mile. Okay. So looking at these answers now, I can determine which one is more dense. And I also can compare them. So if I wanted to look at Brooklyn and Manhattan, I can say that, Manhattan's more dense. It's about twice as dense as Brooklyn. Okay? So the order from most dense to least dense would be Manhattan, Brooklyn, Bronx, Queens, and Staten Island. So Manhattan's obviously, pretty big, okay? And we know there's a lot of people there. And they're going to be more dense. It's more crowded than Staten Island. Okay, so let's look at C. So C says compare the most densely populated, okay, in New York to the least densely populated. So right now I want you guys to take a second and I want you to think about what ratio am I going to be setting up for this? Okay, so the ratio that I'm going to be setting up is we're going to be looking at my most to my least. Remember, this 2 really means to divide. So I'm dividing my most by my least. So I believe that was Manhattan over Staten Island, which is 73,663 people per square mile over 8,557 people per square mile. And we get roughly 8.62. So what does that mean? Okay. So I want you to put that ratio 8.68 into sentences that compare the two densities. So the sentence that I have is that Manhattan is 8.62 times more dense than, or dense as, or than Staten Island. That should be an A there. Okay. You could have also wrote the density of Manhattan is 8.62 times the density of Staten Island. Anything that really has that word times, okay, and kind of tells me that Manhattan is, greater or more dense than Staten Island. So let's look at question 2. So question 2 says the Dominican Republic has a population of about 10.1 million people per 19,000 square miles. Somalia in East Africa has almost the same population as the Dominican Republic, but this population occupies 246,000 square miles. So if someone tells you that Somalia is denser than the Dominican Republic, using your estimation skills, do you think that this is correct? Why or why not? So I want you to tell me, which one do you think is more dense? Do we think that Somalia is more dense? Yes or no? Or is it Dominican Republic that is more dense? Okay, So we need to remember that my formula is population, okay, over area. So if they're both populated the same amount, but we're dividing by a different number, okay? Remember, if we're dividing by, 1 divided by 2 is 0.5 and 1 divided by 4 is 0.25. It's smaller, okay? So we had to think about what happens when I divide by a bigger number. In this case, okay, Somalia is actually is going to be less dense, okay? Because there is going to be less people, I'm shorthanding people, per square mile, okay? So it's bigger. The place is bigger. If we think about 2 subway trains, let's say, right, and one of them is bigger than the other, and I put the same amount of people on it, the subway train that's bigger, the people in there are going to be able to be more spread out than the subway train that is smaller. So actually, let's take a look and let's actually go over and see what is the population density for each of these, okay? So remember, we take my population and we have to put this into standard form, divided by my area, and we get about 41 people per square mile. And then we do the same thing for Dominican Republic. And this is people, and this is square mile. We get 53.6 people per square mile. So if we notice, this only has 41 every mile, and this has over 500 every mile, okay? So obviously it looks like Dominican Republic is going to be a little more crowded than Somalia. So let's look at that next question. Slovakia in Eastern Europe is almost exactly the same size as Dominican Republic, but the population is about 5,500,000. Using as summation to compare in percent how densely populated Slovakia is compared to the Dominican Republic. All right, so let's look at this. Right off the bat, they're almost the same size, okay? So they're about that 19,000 square feet, all right? But my population is cut in half. So which one do you think is going to be more denser based on that information? Okay, so let's try it out. Let's see. So what is the population density of Slovakia? We have 5,500,000 people. And now we're dividing that by 19,000 square miles. And we get about 289.5 for every 1 square mile. Okay, so we see that Dominican Republic is still going to be a little more crowded. It's actually going to be twice as crowded, okay? And we can find that by finding the percent, okay? So if I have 289.5, that is my Slovakia, okay? And my Dominican Republic population density was that, we get roughly 54%, okay? More crowded, okay? So since we know that the population is about twice as big, then we can say the population density is going to be twice as big. And this only works when they have the same area. Okay, we can automatically assume that. If my areas were different, as like this problem that we did above, okay, we can obviously come up with a percent, but we can't just assume. All right, we'd have to actually do these calculations. So I'm just going to write a little sentence. So since the population, and I'm just going to shorthand right now, of DR is twice as big, its population density is going to be twice as big. So what does that mean? That means two things, okay? The larger the country, the more dense it's going to become. All right, so my DR was larger, so it's the more that it gets, if more people are added, the more dense it's going to be. Also, the smaller the area it is, it's also going to be more dense. All right, so if we look at this first question up here, we see that the DR is 19,000 square feet compared to Somalia, which was 246,000 square feet. So the smaller the area, the more dense my population is. So we might want to write that down. So I'm just going to write it on this. Okay, I'm going to write on this next page. Okay. So larger the country is, the more dense it becomes, and the smaller area it has, it also becomes more dense. Okay? So as my population increases, so does my density. As my area decreases, so does my density. All right. So let's look at question 3. So City Island in the Bronx is approximately 0.4 square miles in size and has a population of approximately 4,000 people. What is the population density of City Island? Be sure to include correct units in the answer. So right now, okay, I want you guys to take about 2 minutes or a minute, okay? And I want you to write down the density of City Island, including the units. All right, so remember, density, okay, is my population or the amount of people over area. So in this case, my population is 4,000 people, and my area is 0.4 square miles. So when you guys divide this, you get 10,000 people over 1 square miles. Now, when you guys were probably doing this, you were like, wait, that doesn't make sense. There's more people here than here. But if we look down at my area is less than 1 mile. So remember, whenever we're going in the standard form, we're thinking about per mile. Okay, so density is per mile. So per mile, or per feet, or whatever that is, but the standard, that 1 mile that we're looking at, we can have 10,000 people. Okay? If we cut that mile in half, we're going to have 5,000 people. So 0.4 square miles is only going to have 40,000 people. Okay, so this does make sense because this is less than a mile, so this needs to be greater. So let's look at problem situation number 3. Suppose that 50 years from now, global warming has melted Greenland's glacier raised the sea level so that the city island shrinks to half of its former size. However, the same number of people still live there. So before doing any calculations, decide if you think the population density of City Island will increase, decrease, or stay the same after the effects of global warming, and explain your answer. Okay, so it's becoming smaller, okay? So that's what we know. So it became smaller, okay? So what do you guys think is going to happen to my population density? Well, my population didn't change, but my size did. So that means that there's going to be not more people, but it's going to be crowded, okay? So my people, or my residents of this, will be more crowded. So that means that my density, or my population density, will increase. It will become more dense. Okay? If you think about two squares, if I have one square rectangle looks like that, but I have one square that's a little bigger, okay? If I have 5 people, my 5 people here can be spread out, where here they're really close together, okay? So that's what A is really talking about. B, so we want to calculate after global warming. So if it's half the size, and my size was 0.4, now it's only 0.2. So can you guys calculate the population density? Okay, so density is population over area. So that's 4,000 people. But now I have 0.2 square miles. So every mile there's going to be about 20,000 people. Okay. And question number 2 says, suppose a waterproof high-rise building is constructed in the middle of the island and everyone abandons their apartment and moves to the building. What will happen to the population density on the island overall? So what's going to happen to this density on the island? So it's going to have the same density. Okay, we're not losing people, we're not losing land. All we are, we're just moving them. Okay, but if I were to still spread them out, okay, I still have that. If this is half the island, okay, if we're going off question 1, then I'm still going to have that 20,000 people per square mile. Will that high rise be very crowded? Yes. Okay, the density of that high rise is changing, but of the overall island, it's staying the same. The last thing that we're going to look at is problem situation 4. So according to the New York State Department of Health Bureau of Emergency Medical Services, each classroom should have about 17 to 22 square feet per student. Now this is obviously before COVID. During last year, I believe it was 36 square feet per student. It had to be, okay, or more. Now that 17 is my minimum. I can't go below 17 square feet per student. That 22, it's not really a cap. There's no maximum amount. If you have the space, if the school has the space, they can spread it out, okay? Especially in New York City schools, you can only have 34 students per class. So if they have a really big classroom, and I try to think of some classes that are really big, like Mr. Muhammad's at the end of the hall in 365 or even 364. Those are really big classrooms. You still have the same amount of kids, but you can fit more desks in there. You can spread them out more, okay? So the 22, that really is not a cap. You can go higher than 22 square feet per student, but they say roughly it should be somewhere between 17 and 22. So based on this information, what should the size of the classroom with 25 students B. So first, let's look at this. Is 17 square feet per one student represent the population density? So no, it does not represent the population density because, actually we don't need this per, just one student, because the population density has my population on top and my area on the bottom. So this is actually flipped. Okay, so this is not population density. So how am I going to find out, or how am I going to calculate what should be the size of my classroom? If I know that one student needs 17 square feet, what am I going to do? Okay, so you're going to multiply. I'm going to multiply this by 25 students. When I multiply this by 25 students, I get 425 square feet. So when I look at my classroom better be 425 square feet big. Okay, and the max, or 22 square feet, it can be anywhere between. Okay, so if I do this and I multiply this by 25 students, then it was 550 square feet. Now, if I think about COVID, okay, and I said that it had to be 36 square feet, right, because it had to be 6 and 6, then 36 times 25 would have been 900 square feet. So last year, if I wanted to fit 25 students in my class, I would have to have a room as big as 9,000 square feet. And that's actually why we did not use my room last year, because my room is a little bit on the smaller side. So remember, more space per person just means bigger classrooms, okay? So let's look at this next one. So does a classroom of 650 square feet containing 23 students comply with the standards set by the New York State Department of Health Bureau of Emergency Medical Services? So here I want you to calculate, okay, what is the area per student? If I have 23 students in this 650 square feet classroom, does it comply? Is it between or greater than that 17 square feet? So I want you to calculate that right now. Okay, so we take 650 square feet and I want to divide it by that 23 students. So this is going to be 28.3 square feet for every one student. And this does comply because it's greater than that 17 square feet. Every student is given its own 28.3 square feet. Okay? All right, so for homework that's attached to this, I want you guys to do the 2.1 on My Open Math. Question number 8 should ask you to select the correct answer. I'm going to look to see if I can change that. But if I don't get to change it, just know it should say select the correct answer. And a number of these problems and past problems have scientific notation, so that's why I had that Edpuzzle up there for you guys to review the scientific notation. All right, and any notes you want to write for the scientific notation, I would just write it on any blank spots you have in this book, like the back of the front page, or even on the front page or the back of the book, okay? Just so you have it there. And I will also be on a remind if you guys have any questions about 2.1 or scientific notation.